Hello friends, welcome to Nand Kishore classes. Today's lecture is going to be very interesting because today we are going to learn Pascal's triangle. Now first of all, what is Pascal's triangle? What is the use of Pascal's triangle? This is very interesting topic. We have learnt this algebraic identity a plus b whole square or maximum a plus b whole cube, right? These are the two identities. Usually we learn it. Let me write here. This is a square plus 2ab plus b square. And cube also, like a cube plus b cube plus 3a square b plus 3ab square. That is what we usually learn it. But what happens after that? If it comes for a plus b power 4 like this, a plus b power 4 or a plus b to the power 10, let's suppose, then what will you write? It becomes very difficult. Pascal's triangle helps us to write a plus b power 4, a plus b power 5. It is very easy to expand. So let us start studying how Pascal's triangle looks like. First of all, what we do, I'm writing a number here, 1. Okay, I'm going to make a pattern. Everybody should try to understand now. 1, then write 1 and 1 on both sides of it, left and right, in the next row. Same way, next also, 1 1 1 1. See, I have written so many ones, right? After writing all these ones, we are going to fill the blanks in the middle. For example, this is 1 and 1. 1 plus 1 is 2. Just add them and write in the middle. That's what we need to do. Here 1 plus 2 is 3. 2 plus 1 is 3. See, write it accordingly. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. That is how we need to fill the inner values. We can write one more step, two more steps. As more you want, you can keep on moving. Now, what is the benefit of writing it? See, benefit of writing it is like a plus b to the power 1. Let me focus on first of all a plus b to the power 1, because everybody knows power 1 is not going to change the value. A plus b power 1, it will remain a plus b, right? How many terms are there? If my exponent for this binomial was 1, I am finally getting 2 terms. Now that means this 1 1 is corresponding to this one, because there are 2 terms I am having, 1 and 1. That means a plus b power 1 corresponds to second row of my Pascal's triangle. Yeah, one more point, why it is triangle, because you can join these lines. If you join 1 to 1, bottom line and this line, it will show you a kind of triangle only. That is why Pascal's triangle is called. Then if I start writing a plus b square, please focus very carefully. This first line represents a plus b. This third row, it represents a plus b whole square. Now the question is, sir, how it represents? Try to understand. Actually, this 1, 2 and 1, these are the coefficients written for each term after expansion. Coefficients. Like it is a plus b whole square. How to expand it? First value, square of it. Last value, write square of it, like this. First value and last value will definitely have same exponent as it is showing here. But after that, what will happen? A square, reduce its power by 1. It will be left with only a power 1. Power 1 is not necessary to be written. And add 1 b to it. Then if you reduce power of a more, that means already it is a power 1. if you reduce a power 1, more 1 power is being reduced, that means it becomes a power 0, which is not written, so b is increased. When I will write a plus b whole cube, then you will get better idea, because see, a cube and b cube I am writing. Okay, a cube and b cube I am writing. Now what happens? What is the next term? Cube becomes square and add b to it. A square becomes only a, then increase b, and after that a is reduced, b is increased further, so we get b cube. That is how the flow goes. And these are the coefficients, like for a plus b whole square, 1 2 1 was there, that means a square will have only 1, this will have 2, this will have 1. 1 2 1. Let me write it again. This is 2, a square is having 1 coefficient, b square is having 1 coefficient, that is not required to be written, because 1 a square and 1 b square both are same. So that means this 2 represents 2ab. Moving ahead, 1 3 3 1 means 1 is not required to be written with anywhere, but second and third term are having 3 coefficient, that means this is 3a square b, this is 3ab square. That is how we need to write it. I'm moving to a plus b power 4, which is nobody remembers it, even we don't tell any student to learn it. It can be applied using this line. This line represents a plus b cube. This next line represents a plus b power 4. How it represents? Check it. First one is a power 4, and I'm telling you next one is a power 4, then write a power 3, add b, because b was missing earlier. Remove one more power, it becomes a square, then b square, then a b cube, and at the last you have b power 4. That is how the flow goes. It starts from a power 4, we keep on reducing the power of a and keep on adding the b, and at the end a is gone, only b power 4 is left. And now what are the coefficients? 4 6 4. That means this is having coefficient 4, this is having coefficient 6, this will have coefficient 4, add it. So see, this is the expansion of a plus b power 4. It becomes very easy to remember or write if you are very much clear how to plot it. And it is not the end. Like if you want to write for a plus b power 5, we can write it very easily. You just will have to add 1 1 on the right side of it. Add 1 here, 1 on this side. 1 plus 4 is 5, 6 plus 4 is 10, 6 plus 4 is 10, 4 plus 1 is 5. And now if I start writing a plus b to the power 5, what will happen? Firstly, only a power 5, right? Then in the next term, a power 4 and b will be added, and take second coefficient from here. See, this is 5 will come here. And then a is reduced, b is added, a cube b square, and next coefficient is 10. So write 10 here. I hope you are finding it easy now. Next coefficient is again 10. A cube will become a square and b cube, right? Next coefficient is 5. I'm writing here at the top after that. Next term will be single a but b power 4. But yes, its coefficient is obviously I need to add. Coefficient is 5, ab power 4, and at the end it is only b power 5. That is how we can expand. Same way you can go for expansion of a plus b power 6, a plus b power 7. This is the expansion of binomials. Even though Pascal's triangle is not the only way of expanding any bracket or expanding any binomial. Binomial theorem is there, where different kind of expansion is there, formula is used related to combination C, formula is used, that we can also cover up in our upcoming lectures. But I hope you are clear with the Pascal's triangle which we covered today. Thank you so much for watching.